सर लाइव आएगा अभी 1 मिनट में।
सर आप बता दीजिएगा जब हो जाए तो।
क्या क्या स्टार्ट करना है? व्हाट यू आर सेइंग?
सर okay sir, good morning sir. Today we are organizing an webinar on linear measurements. Today we are having Dr. Manoj Kumar Gupta with us. He has completed his PhD from NIT Kurukshetra in 2013 and his bachelor's and masters are also from NIT Kurukshetra only. He is having a experience of 16 years in teaching and 8 years of industrial experience. He has worked at various positions like he was HOD of Mechanical Engineering Department at SKITE Kurukshetra. He has taught 15 subjects related to mechanical engineering. He has attended more than 50 short-term workshops and organized many of them. He has published around 30 papers in international as well as national journals. He has worked with one of the German companies in which he was handling the 40 megawatt diesel power plant project from Germany. Now, right now, he is working as a professor at Chandigarh Engineering College, Mohali. I welcome you, sir, on the behalf of Parul University at for giving us your precious time for this webinar. I welcome you on the behalf of our principal Ruchi Srivastava ma'am, our HOD Bindi Thakkar ma'am, and all the staff and all the students of the Parul University. Welcome, sir.
Thank you, Amit.
Sir, we can kindly start. We can kindly you can kindly start your webinar, sir.
Yeah. Thanks, Amit, and thanks all of you. Amit has been my student, one of good students at SKITE Kurukshetra, and today I will present a presentation on metrology and instrumentation. This is the first unit of your syllabus. I have seen your syllabus also. It is very nicely set and explained a lot also. So first chapter is of linear measurement. In linear measurement, we are using scales. We are using scales. We are using vernier caliper. We are using micrometer. This is also vernier caliper. It is used as a depth gauge. It is used to measure the inside depth of a cylinder or a machine part. It is also height gauge. It is height gauge. It is used to measure the height. And these are the slip gauges and limit gauges. Next, I have shared a two YouTube links on limit gauges and slip gauges. So first is linear measurement. Linear measurement is measurement of perpendicular distance between 2 points or surfaces. There are 2 points or surfaces. We are measuring the perpendicular distance between them. So in this case, length, height, diameter, thickness, radius comes. And these instruments are marked. These are having graduations on them and it is neatly written on them at a regular distance. Next is classification based on methods of measurement. First is direct measuring instruments and next is indirect measuring instruments. So second classification is also there, graduated instruments and non-graduated instruments. Graduated instruments include steel rules, that is scales. Rules matlab steel scale ya ordinary scale is also there. Vernier caliper, vernier height gauge. I have shown the figures. What is vernier height gauge, vernier depth gauge, micrometer, dial indicator. Once again, I go back. This is height gauge, vernier height gauge. This is vernier height gauge. This is vernier depth gauge, and these are the slip gauges. These are the at the lower corner are slip gauges. These are non-graduated instruments. There are also uh, calipers, wire gauges, screw pitch gauges, radius gauges, thickness gauges. Graduated instruments I have shown you. This is micrometer, this is vernier caliper, this is height gauge, this is depth gauge. And non-graduated instruments, this is caliper. This is used to measure the inside diameter. And this is also caliper. These are also calipers. And these are of adjustable type. There is a nut and there is a screw here. It is having thread and there is a adjustable nut. We can expand or decrease the distance between the two tongues of this caliper. This is inside type, this is outside type. And this is a wire gauge. This is a wire gauge. It is having holes. These are holes. These are of different sizes holes. And if we want to measure the diameter of a wire, we insert the diameter inside these holes. We insert the wire inside these holes. These are the outer holes. The wire is inserted in the outside holes. And the diameter into which the wire fits is the diameter of the wire. Suppose this is written as 7, this is 8, 9, 10, and these are up to 50. This scale is up to 50. So 50 SWG. SWG means standard wire gauge. 50 is the diameter of the wire, and this is the 1 is the diameter of the wire. 2 is the diameter of the wire, the hole into which the wire inserts nicely is the diameter of the wire. And we can convert this SWG into millimeter. I have sent through WhatsApp to Mr. Amit the conversion table of SWG into millimeter. We can convert SWG. SWG is a British measurement and millimeter is an SI. In India, we use SI system. So we can convert SWG into millimeter. Or there is one more gauge known as AWG, that is American wire gauge. AWG full form is American wire gauge. The conversion is slightly different. So, for example, the diameter of wire is 1 SWG. Then in millimeter it will be 7.62. If it is 24 SWG, then the diameter in millimeter will be 0.559 millimeter. So if we are increasing the gauge from 1 to 50, the dimension in millimeter will decrease. For 1 SWG, it is 7.62, and for 50 SWG, it is 0.024 millimeter. So you can imagine that in millimeter how it is converted. One more conversion is there, AWG, that is American wire gauge. Next is, it is shown in the figure, screw pitch gauges. In your workshop, these instruments, these measuring instruments, these gauges might be available. You can see all these gauges in your workshop and do the measurements with your own hands. Every student should practice this. He should be able to measure the diameter of the wire with the help of this wire gauge. Or this is screw pitch gauges. There are leaves, there are number of leaves on both the sides. So, and threads are also marked on these leaves. So if there is a bolt on which threads are there, then we can check with the help of these leaves. With the help of these leaves, we can check the threads. How much it, suppose it is M20, M6, M8 or any other M30, M40, etc. And pitch is also written sometimes on these leaves. It is 3 millimeter, it is 4 millimeter, 5, 6, etc. On the leaves, the value of metric thread is written, and pitch is sometimes written. On this side there are also threads, so we can have different systems. We can have one side, this is metric threads which are used in India, but in case of UK British system, the British threads are used. It is known as BSPT or BSW thread. Full form is British Standard Whitworth. In British system, it is BSW threads or BSPT. In case of pipe threads, it is British Standard Pipe Thread. In India, we use only the metric threads, but in America, we use the ANSI system, American National Standard. There, the system is different, but in India, it is metric threads. So linear measuring instruments, classification based on accuracy, non-precision instruments. So the steel rule which we are using, it is a non-precision type instrument. Steel rule. The rule which is available in workshop is made up of steel. But in drawing instrument, engineering drawing and graphics, we are using some different material steel scale. Caliper is there, divider is there. We can measure the distance with the help of divider, or we can divide the arc into equal number of parts with the help of divider. Depth gauge is there. I have shown you telescopic gauge. We will see in the next slides. Precision type instruments, vernier caliper, vernier height gauge, vernier depth gauge, micrometer, slip gauges. These are precision type instruments. We can do the measurement precisely. That is also to some extent precise, but that is not to that extent precise. It is very precise measurement with the help of vernier caliper, micrometer, etc. With the help of steel rule, we can take the distance 5.4 millimeter, but beyond that we cannot go. But if we want to go up to 2 decimal places, we have to use vernier caliper or micrometer, etc. So these are the various diagrams of the measuring instruments. It is showing this is vernier caliper, but this is of digital type. There is an indicator on this, the reading is coming. This is also digital type. There is a dial, and on this digits are written. This is also digital type. This is also digital type. This is micrometer. We have to take manual readings on this. This is manual. It is having dial gauge also. This is vernier caliper, but this is having dial gauge also. This is also vernier caliper. These are the dial gauges. Dial gauges. They are having probe at the bottom. We can measure the deflection. Sometimes we have to measure the deflection, so we can measure with the help of dial gauges. This is the filler gauge. Filler gauge. Sometimes we have to measure the gap between two mating parts. In the IC engine, we have to check the clearance. Tappet clearance we check, so we can measure that distance with the help of filler gauge. We are having various leaves. We are having various leaves of various thickness. The thickness is varying in case of filler gauge, and we insert the leaf between the gaps of two mating parts and check the gap. So all these instruments are shown in this PPT. This is steel rule. We all know this is the workpiece and this is the scale, and what is the method to measure the distance. Suppose this is the mark, and we should be in front of this, correct? If we see from the upside or downside, then there may be some error, and that error is known as parallax error. So we should be in front of the arrow, then only we can take the reading. This is workpiece, this is scale. There should not be gap. The workpiece should touch the scale. Now next comes least count. In case of vernier caliper or micrometer, we have to calculate the least count, then we can take the measurement. So what is least count? Least count is capability of an instrument to measure minimum distance. Suppose we want to measure up to 0.01 or 0.02. So then this is the least count, the minimum distance which we can measure accurately with the help of that instrument. Every instrument is having his own least count. Every instrument is having his own least count. It is varying from one instrument to the other instruments. And one more definition is there. It is the difference between value of main scale division and auxiliary scale division, MSD minus ASD. So now we take vernier instrument. Vernier instrument least count is value of minimum divisions on the main scale, number of divisions on the auxiliary scale. So this is the vernier caliper and it is the main scale. जो upside है वो main scale है, that this is the main scale, and downside is the auxiliary scale. Downside is the auxiliary scale. This is a revolving nut and we can slide this auxiliary scale on the main scale. This is a fixing screw. This is a fixing screw. We can fix the position of the movable. This is auxiliary scale with this help of this screw. This is fixed jaw. This is movable jaw. Now we are calculating the least count of vernier caliper, vernier scale division. Suppose this is the main scale and this is the auxiliary scale. So 49 main scale we take up to 50 millimeter, and 49th mark on the main scale coincides with 50th number of vernier scale division. You are listening, so I want your attention to this point, that 49 main scale division, main scale on the main scale, this is the division, and 49th mark on the main scale coincides with 50th mark on the auxiliary scale. This is the vernier scale. Then 49 main scale division are equal to 50 vernier scale division. Vernier scale division is the auxiliary scale division. From one main scale division is equal to 1 millimeter. On the upside, one main scale division is equal to 1 millimeter. So one vernier scale will be equal to 49 by 50. So this will come as 49 by 50.98. So least count is 1 MSD minus 1 VSD. You can divide it. You can divide 49 by 50. It will come out to be 0.98. So one vernier scale division is equal to 0.98 millimeter, and one main scale division is equal to 1 millimeter. So if we subtract 1 millimeter from 0.98 millimeter, the value comes out to be 0.02 millimeter. So the least count of the vernier caliper is 0.02 millimeter. I think now it will be clear to you how we calculate the least count of a vernier caliper. We take main scale divisions and vernier scale divisions. We equate them and calculate the least count from 1 MSD minus 1 VSD. Least count of micrometer. Next comes least count of micrometer. So what are the various parts of this micrometer? This is the main scale. This is the main scale. Okay. On the upper side, these are graduated at every 0.1 millimeter. 1 millimeter gap is there. 1 millimeter gap is there between two graduations on the upside, and between the two graduations on the upside, on the lower side, there is one more mark. Between two graduations on the upside, there is a graduation on the downside. So it is showing 0.5 millimeter. It is to show the 0.5 millimeter between one lower mark and one upper mark. So this is the barrel, this is the thimble. Thimble, it is having 50 graduations. It is having 50 graduations. It is the thimble. This is the whole millimeter. This is datum line. This is half millimeter. And each thimble division is equal to 0.01 millimeter. So least count is equal to value of smallest division on main scale divided by number of divisions on auxiliary scale. Least count is equal to value of smallest division on main scale. It is equal to 0.5. Value of smallest division on main scale. This is the main scale, and this is equal to 0.5. And number of divisions on the auxiliary scale, this thimble represents the auxiliary scale. It is equal to 50. So least count will be 0.5 divided by 50, and it comes out to be 0.01 millimeter. This is again vernier caliper. Its construction is shown. This is the fixed jaw. This is the sliding jaw. This is vernier caliper, vernier scale. This is the main scale which is fixed. This is locking nut. These are for internal measuring faces. Suppose these jaws are to measure the outside diameter, and these two jaws are used for measuring the inside diameter. This is for fine adjustment. First we have to fix this, then we can do the fine adjustment with this. And this is the depth gauge. This is the depth gauge. Vernier caliper is shown in this figure. How we can make the dimensions? Suppose we want to measure outside dimension, we can use these jaws, outside jaws. And if we want to measure the inside diameter, there is a hole in this object. We have to use the inside jaws in this. And then suppose we want to measure the depth of this hole, then there is a gauge on the back side of this. We can use that depth gauge and measure the depth of the object or hole or cylinder. These are the various errors which are encountered in vernier calipers. There is play between sliding jaw and fixed scale bar, then there will be error. And if the jaws are weared out, then there may be error. And if we take incorrect observations, parallax error is there, then there will be error. We should not use the excessive force too on the movable jaw. And line of measurement does not coincide with the line of scale. These are 5 errors in vernier calipers. And these are the precautions. No play should be there. Jaws should not be worn out. And this is properly balanced in hand. Do not push the moving jaw. These are the precautions which we have to take before measuring while measuring the dimensions with the help of vernier caliper. This is the height gauge. Earlier also I have shown the height gauge. And what is the construction of this height gauge? This is the base of this height gauge. This is the main scale. This is the vernier scale. This is the fine adjustment screw. This is guiding surface, and this is the vertical bar. This is the clamping screw, and this is the bracket, and this is the scribing job. This is the construction. You might have seen the vernier height gauge in your workshop. There is a vernier height gauge in a workshop. With the help of that, we can measure the height of the object. Depth is measured with the help of vernier depth gauge or vernier gauge. But the height is measured with the help of height gauge. There is difference. There is difference between depth gauge and height gauge. So this is a cube, this is a square cube, and this height is to be measured. This height is to be measured of this workpiece. Then we will place this on the table, level table, and the jaw will strike at the top of this. Then we can measure the height of this block with the help of this scale. This is the main scale, and this is the vernier scale. Similarly, we can calculate the least count, and then main scale reading, vernier scale reading. We can convert that reading into the dimension of this height. Then vernier depth gauge is there. Similarly, so we can measure the depth. This is the depth measurement. Suppose this is the block, this is the workpiece, and it is having an inside cut in this, and we can measure this depth. We have to measure this depth from this point to this point. This is the depth of this workpiece. With the help of this depth gauge, we can measure the depth of this workpiece. Micrometers. Similarly, micrometer is there. Then we can do the measurement. This is the dimension. This is the anvil, and this is a U shape, and this is the dimension. This is the gap between 2 points. So we can place the object here and do the measurements. This is the lock nut. This is the barrel. This is the barrel, and this is the thimble, and this is main scale. This is main scale. This is thimble with auxiliary scale. This is the auxiliary scale, and this is the main scale. This is the construction of micrometer. This is the picture of micrometer. This is the anvil, and this part is known as spindle. And least count is also written on this. Range is also written. We can measure 0 to 25 millimeter, and least count is 0.01 millimeter. On every instrument, the least count and range are written. You can see the instrument and check that what is the least count and what is the range. And you can calculate your own least count also by providing this procedure as I have discussed, and check that the least count which you have calculated coincides with the least count written on the instrument. This is the lock, this is sleeve, this is the main scale, this is the main scale, and this is the auxiliary scale. This is ratchet knob, this is thimble, and this is how we are. This is the graduations on the micrometer. And suppose this is the circular object. Circular object is there whose diameter is to be measured. So we will take, this is the reference line. On the above side it is main scale reading, and this is vernier scale reading, and this is reference line. We will take main scale reading, and we will take the auxiliary scale reading. So total reading, what is the measurement from the micrometer? It will be equal to main scale reading plus least count multiplied by reading on the thimble. Suppose the reading on the main scale is 13.5, and reading on the thimble, that is the auxiliary scale, it is 35. It is 35. We will multiply the reading on thimble with the least count and then add the main scale reading into it. Then total dimension comes out to be 13.85 millimeter. So we are getting accurate reading up to 2 decimal points with the help of micrometer. We can take the dimensions of cylinders or circular object with the help of micrometer, and with the help of vernier we can take the dimensions of cubes, rectangular objects or square objects. And these are the various types of micrometers: outside micrometer, inside vernier, depth micrometer, bench micrometer, digital micrometer, etc. This is the inside micrometer. This is the depth micrometer. There is a depth gauge too. Vernier micrometers are also there. Similarly, we can calculate the least count of this 0.01 millimeter. And this is also vernier micrometer. We can take the reading of the main scale, and we can take the reading of auxiliary scale. And its vernier micrometer least count is up to 3 points, 0.001 millimeter. Earlier it was 0.01 millimeter up to 2 decimal point, but this least count is up to 3 decimal points, 0.001 millimeter. And similarly we have taken the dimension, it comes out to be 11.626. We will take the thimble reading, we will take the main scale reading, and then vernier reading too, and we will total add up all the 3 readings. We will take thimble reading, we will take vernier reading, and we will take main scale reading. In vernier micrometer we have to take 3 readings. There are 3 scales, but in case of micrometer or vernier caliper there are only 2 scales. We have to take only 2 readings. In this there are 3 scales. Now next comes the telescopic gauges. Telescopic gauges, this is an instrument for indirect measurement. Indirect measurement, it is used to measure the diameter of holes, slots and grooves. Holes, slots and grooves. It consists of handle, 2 telescopic rods and locking screw. This is locking screw, this is handle, this is spindle, and these are the telescopic rods. One is this, one is this, and this is the workpiece. It is having 1 inside grooves. It is having 1 inside groove. This is the workpiece. Now we want its inside dimension. We want the diameter gap of this. Then we can do exact measurement with the help of telescopic gaze. We insert the telescopic gaze inside this and take the measurement. Suppose this is the connecting rod. What is shown in this picture is this is connecting rod. ये connecting rod है जो IC engines में use होती है, and this is the small end bearing and this is the big end bearing. Small end bearing inside dimension and big end bearing inside dimension we can take with the help of telescopic gaze. This is the telescopic gaze, and these are this packet contains various telescopic gazes, and it is written on the telescopic gaze also, and this is also written on the packing tube. Packing tube it is written. Okay, so connecting rod, I have told you, this is the big end bearing, and this is the small end bearing. Small end bearing is used to connect the connecting rod with the piston. There is a pin in this hole, and there is a bearing inside this. Push bearing type is there, and this is the big end bearing. This is used for connecting the connecting rod with the crankshaft, and we want the exact dimension, very precise dimension of these, because we have to fit the bearing inside it. So telescopic gauge is used to measure this inside hole dimension. If we want the inside hole diameter, we use the telescopic gauge. Next comes slip gauges. Slip gauges. I have sent you YouTube link of limit gauges as well as slip gauges. So you can see these videos. These are 5, 6, 7 minutes only, and you will be able to understand how the measurements are done with the help of slip gauges or limit gauges. So we are having the various blocks. 1, 70, 1 after 1 it is 1.001, 1.002, 1.003. These are the various rectangular blocks, and देखिए ये 1 after 1 it is 1.001 and 1.01, and it is 1.1, 1.2, 2, 3, 10, 20, 30, 40, 50, 60, 70, 80, 90. So various types of blocks are there. We can do the exact measurement with the help of these slip gauges. And this 10, this is the 10 number. This dimension is 10. This is also 10. This is also 10. Suppose we want the measurement of, we do the slip gauges of 70 plus 30 plus 1.5. So 70 plus 30 will be plus 1.5. So this is 100, 101.5. We can use 3 slip gauges or 2 slip gauges or more than 3 also to make the required height. And we can take the exact measurement with the help of these slip gauges. These are also slip gauges. These are shown in this diagram. 1, 2, 3, 4, 5. And these are universally accepted and standard of length in industry. A rectangular block made up of high grade hardened steel, and this high grade lapping to a high degree of finish, flatness and accuracy, size or shape. These are the slip gauges. Slip gauges is running. Earlier it was telescopic gauge. Now this is slip gauge. These are the slip gauges. Its dimension is given: length, width and thickness or depth it has taken. These are the slip gauges. The ringing process is used to build up desired dimension over a range of sizes in specific increments. We have to make a desired dimension. Suppose I have shown you the example of 101.5 millimeter. We want to make this dimension, then we can take a block of 70, then 30, then 1.5, and we can add up. First 70 is coming, then 30 is coming, then 1.5 is coming, then 101.5 is the complete dimension. We can take this complete dimension with the help of slip gauges. It can be put one below and one above. It can be put like this also and like this also. These are the slip gauges, and they are used to check the accuracy of verniers, micrometers and other measuring devices. We want to check the accuracy, then we will use the slip gauges. they are used for direct precise measurement. They are used for direct precise measurement. Limit gauges. Limit gauges also are of go and non-go type. These are of go and non-go types. What are these? Suppose we want to check the tolerances. ये लिखा है इसमें maximum metal limit and minimum metal limit. Maximum metal limit and minimum metal limit. We want to check the tolerances. There are two sides of the limit gauge. One side is go gauge and other side is no go gauge. And we want to check the inside diameter or bore of an object. Then from one side it will go inside the bore, and from the other side it will not go inside the bore. Then with the help of that limit gauge, specific limit gauge, we will check that object, we will check that inside bore. These are the limit gauges. These will just pass, go or not go, inside the hole. It is written as the various types of gauges are plug gauges for checking holes. These are snap and ring gauges for checking shafts. These are of single limit, double limit, single-ended, double-ended, fixed and adjustable gauges. I have sent you a YouTube link. You can see that link and judge how the limit gauges are working. It is nicely shown and you can understand from that too. These are the types of limit gauges: inspection limit gauges, reference limit gauges and workshop limit gauges. The figures are also given: cylindrical pin gauge, adjustable gauge, thread plug gauge, cylindrical plug gauge. These are the two sides. This is go, this may be not go side, this may be go side. From one side it will go inside the hole, from the other side it will slightly not go inside the hole. So these are of two side type. This is single side type. These are the thread adjustable thread ring gauge. ये लिखा है, this is go, this will not go, and these are threaded type too. On this also you can see this is 12.6 to 12.90 millimeter limit gauges. Snap or gap gauges, limit gauges. This is not go, this is go. From this side, on the one side too there are, this is go side, from here it will not go. These are having two ends, one is go type and other is not go type. This is adjustable anvil, and this is the classification: steel rule, ordinary caliper, least count, vernier caliper, micrometer. What is the principle, construction and working, reading types, errors and precautions. In gauges it comes slip gauges, telescopic gauges and limit gauges. So one thing I want to tell you about the metrology and instrumentation. There is a system of units known as SI system. This means System International. In 1960, this system, SI system, was implemented. It was adopted. It is having kilogram for measuring the mass, meter for measuring the length, second for measuring the time, ampere for measuring the current, degree Kelvin for measuring the temperature, and candela for measuring the intensity. And in India too, it was implemented between 1956 to 1960. So all all the standards, international standards, are kept at Paris. There is a place, there is Paris is capital of France, and all the international standards are kept at that place. So if we want to define, kilogram, what is 1 kilogram? So the mass of a body is defined as the quantity of matter of which the body consists of and can be subjected if matter is added or subtracted from the body. The kilogram, it it represents the mass of international prototype of cylinder of 90% platinum and 10% iridium alloy preserved at International Bureau of Weights and Measures at Paris. So that standard is kept at Paris, and India, there is a National Physical Laboratory of India, and it is located at New Delhi. All the standards are kept there. All the standards are kept there. There are primary standards, there are secondary standards, and there are working standards too. And there are international standards too. International standards are kept at Paris. In India, national standards are kept at National Physical Laboratory of India at New Delhi. And India adopted this system in 1962. SI system international. Earlier there was confusion between the various countries. There is British system to American system to FPS system, CGS system, MKS system. MKS system is slightly different from SI system. Now SI system is there. So all measurements are done in SI system. In that I have depicted 6 units, and in that force unit is Newton and stress and pressure unit is megapascal. So pressure is having so many units: kg per centimeter square, mm of hg, and this is torr ounce per inch square. So there is a quite confusion, but in SI system the unit of pressure is megapascal. 1 megapascal is equal to 1 Newton per millimeter square. So this is all about which we have told you about this presentation. Now you can ask your questions. So now please you can.
Thanks a lot, sir, for your precious time. Our HOD madam is also there. Respected Bindi ma'am. Ma'am, kindly share your views on the webinar. And if students are having any
Uh,
doubt, sir, I will be mailing it you through
Okay.
your email ID, sir.
Respected Manoj sir, on behalf of Parul University, we thank you. And the session was really beneficial for the students. We really enjoyed. Sir, we thank you once again for taking these efforts during this crucial time. So, thank you once again for, on behalf of Parul University, sir.
Okay, madam. Thank you too.
Thank you, sir. Thanks a lot for your precious time. Thanks from behalf of Parul University, from principal, from Bindi ma'am, from HOD ma'am, and all. Thanks a lot, sir.
Okay.
I am ending the sir session.
Okay. Okay.